All right, so now we're going to do activity 1. So you need to have this written down on your paper. If you didn't already do that, like if you didn't see it at the beginning and already copy it down, go ahead and pause the video for a moment and get it copied down real quick. It's just a tally chart for us. Okay, so what we're doing here is we have our die, and we are going to be rolling it 24 times, and we are going to tally how many times we roll each number. Okay, I'm not going to make you watch me do that. I'll do the first one just for an example. Okay, I got a 3, so that's my first roll, and I got a 3, and I don't want to lose, so I can keep count on here, but so I'm going to pause the recording so you do not have to watch me doing all this, and you pause the video and you go ahead and roll 24 times, and then we can restart to discuss in a moment. So go ahead and pause the video and roll your die 24 times and tally up how many times you get each number. All right, so you have your tallies done, and then I'm going to go ahead and fill in my frequencies here. So I rolled a 1 5 times, I rolled a 2 twice, that's ironic. I rolled a 3 6 times, a 4 5 times, I rolled a 5 twice, and I rolled a 6 4 times. So now let's just think about our questions here. So this was basically number 5 here we just did. Number 6 says, which of the 6 outcomes occurred more frequently than you would guess? So what do you think? I mean, I can't look at your paper, obviously. More frequently, mine actually turned out pretty even. I thought it would be more random because I feel like when I'm playing board games, I end up rolling the same number a ton of times, but it actually ended up being pretty even here. So I guess if I had to pick, I would say, 3, because I got more 3s than anything else. Number 7, how many times was the upturned face even? So if I count here, I have 2 and 5 makes 7, 8, 10, 11. So I got 11 evens. 11 times the upturned face was even, which that's kind of interesting because there's 24 rolls, and since half the numbers are odd and half are even, you'd think I would have gotten 12. So I actually got a little bit more odds than I did evens. Interesting. For number 6, oh yeah, I said I was going to say 3 here. And then number 8, based on your table, predict what the next roll would be. What do you think? Look at your table. What do you think the next roll would be? I mean, my guess for me would be a 2 or a 5. Since I was so low on both of those, I would think probably a 2 or a 5 because I would expect it to even out some more. But maybe you think something different. Maybe you think a 3 would be more likely on my chart because I have lots of 3s. So maybe that, I don't know, maybe my hand just rolls it weird that way. Who knows? So that is doing some experimental probability. So let's turn the page and look at the top of the spinner. We are not going to create spinners. We're just going to look at the work that they did for spinners here. At the top of page 594, it says we can perform probability experiments repeatedly to estimate probabilities that we do not know how to calculate. So we've got Serena. She has this spinner here. She does not have any definite plan. Her pieces are not equal, so she really has no way of predicting how often she's going to get a 1, 2, or 3. See how they're all wonky? Anyway, so she creates this tally chart where she spun the spinner 50 times, and she kept track of how many times she got each one. So let's take a look at her relative frequencies. Notice that she rolled, or she spun, I feel like I need to mark this somehow to show that we're done with that. Okay, so she spun a 1 17 times out of 50. She spun a 2 28 times out of 50. And she spun a 3 just 5 times out of 50. All right, so that's our info there. Okay, it's already in your book, but I'm just copying it down so we can be staring at the same thing. All right, so let's read below the chart. Okay, Since 17 of 50 spins stopped on 1, Serena estimates the probability of outcome of 1 to be 17/50ths. So based on her guess, she says, I think I have a 17 in 50 chance to spin a 1. Okay? And she thinks that her probability of spinning a 2 is a 28/50th chance. So, and her probability of spinning a 3 is a 5/50th chance. So let's look at question 9 together. Okay? Follow along as I read. Feel free to read out loud with me if you are like getting tired of listening to me. Because 28/50ths is greater than 17/50ths, outcome 2 seems more likely than outcome 1. Okay? Makes sense, right? So 28/50ths is greater than 17/50ths. So it seems like you'd be more likely to spin a 2 than you would to spin a 1. Your likelihood of getting a 2 is greater than your likelihood of getting a 1. And also 17/50ths is greater than 5/50ths. So you would guess that you're more likely to get a 1 than you are to get a 3. Now let's look at the spinner. If you looked at that spinner, would you say, does this make sense? Does her experiment make sense with the way her spinner looks? And why would you think that? Yeah, I think it does make sense because section 2 is bigger. So it makes logical sense that she would land on section 2 more often. And section 3 is the smallest, so it makes sense that she landed on section 3 the least. So yeah, I would say that that makes perfect sense. All right, let's look at question 10. Number 10. Do you think 28/50ths overestimates the true probability of stopping on 2 or underestimates it? What do you think? Question 10. Do we think that is 28/50ths an overestimate or an underestimate? If you look at the picture of the spinner, what do you notice about section 2? Section 2 is just under a half of the circle. It's a little bit less than a half of the circle. So if I had to make a guess, I would guess that her true probability would be like less than 25/50ths. She would land on section 2 less than half the time. So I would call this an overestimate myself. Okay, I would call this an overestimate. All right, one more video to do activity 2. So go ahead and move on to the next video, guys. You're going to need these little thingies, these cards.